Good morning. Now it will be explained a format how to open an algorithm, well, which task is show the monitoring data all thermodynamical variables for this system. Okay. The trouble with this system is the motor DC because of it has overload, the necessity to work before to replace this motor DC or to repair this motor DC is looking for the steady state, measuring data, and after shut off in order to reduce temperature and to get or to avoid overloads and to repeat procedures while this condition. So the hardware and the computer which is inside the MyRio controller, which make operations and measurements and so on in order to show data. So switch on this power supply, switch on the system, and how to open the main algorithm. For our laboratory, the main algorithm will be stored in LabView compressor, always in this file. Okay, always the point view I file will be stored in this file, LabView compressor algorithm. Not open this, please. This is only for experiments. And why not was designed a .exe file? So I suggest to check the link contained the analysis about the operating systems and real-time, no real-time, and some strategies how to achieve this. Now, the operating system which we have now is Windows, so not real-time, and we will make another path in order to look for open this algorithm. Okay, so how open this? I suggest you know open directly because you will get mistakes. We need to look for the computer which has make control about this algorithm, which is MyRio inside this, connected of course with this processor. Not now. So we look for open LabView. It will be opened. Need to wait. Okay, and after we need to look for a project. There are many projects in this computer and you can associate how to connect with the algorithm in order to open this. So it's a bit not fast. This is the reason to prepare this explanation by video, and also how to look for strategies by operating system in order to make .exe files, but this is another video. Okay, so I want to start LabView now. Okay, so remember, look for LabView, and after we suggest you to look for project, open project, and there are many suggestions, and I suggest you also to look for one of these, which is in the file compressor. Look for file compressor, please. Carambas. Wait. Compressor. No. All files. Okay. Wait. I don't have good eyes. Last compressor algorithm. Okay. And we look for a project. One of projects. It has this format. Like project, could be filtrado in Spanish. You can look for projects. I suggest you don't open directly the file because you will get disbalance or a bad understanding, talking about software, between both controllers. This main controller from this processor of this computer laptop with the main controller of this system. I suggest you also, it must be switched on in order to recognize signals. So, wait. And minimize this, please. Wait a second. Okay, I need to open also this file and medition 34, 38. Every day which you could find the algorithm here, I suggest you to open this because it's the new version of algorithm concerning this research about artificial intelligence for this system. But okay, this is another task which we can discuss in another time. So now it must be introduced here. The algorithm, this, I suggest you to introduce always here. But then in this context it is introduced. Whether it will be say like a conflict because now there are two, and the algorithm will say, hey, which of them you want that I could recognize? Okay, no matter, now no conflicts. So I suggest you to open directly from here. Now it's possible double click, left click. So start to open. So without any kind of trouble. Okay, I suggest you to make these steps in order to achieve this algorithm. Well, this has inside some strategies. In last version it has identification data outside. Now this identification data is inside, like the algorithm will make own recognition by itself in order to get better performance in presence of disturbance. What do you mean? Well, let me to execute this and we will find an explanation by experiment, so a small experiment, please, in order to verify what we are looking for. Remember that we usually work in 2 points, 500 RPM from compressor, talking about the speed, and 1000 RPM for compressor. So I need to shoot on our system. Come on. And we look for the speed in compressor. Wait a minute, or wait some seconds. I don't know, you can see. Anyway, I will be so close. Some seconds. Slowly, in order to don't damage the system. Carefully. Okay. 500. Choose a number, please. 1, 2, 3, 4. Pressure. What happens if we look for 3 bars? Okay, we look for 3 bars. The speed is 500 RPM. Talking about compressor. Okay, we will look for 3 bars. I am closing valve. It is, I don't know, you can check 0.3 bars. Also here we can verify and try to get the control in 3 bars. Well, what we were talking about some weeks ago is that the sensor is not working in this algorithm. It was designed as an observer because it has not good response in another values of the speed. So this is the reason which was designed an artificial sensor or like artificial intelligence, or such as like by another routers like fictitious sensors, because it was observed the flow in order to obtain measurements correlated with a pressure value. But this is an analysis by identification system online, on time talking about, okay? We will try to get the control. Of course, it's not controlled system. I'm not talking about it must not to be controllable. It's not controlled, it's another task. So more or less 3 bars. But we will try to get a steady state, and of course it will never achieve a real steady state because of many disturbances, such as this movement or vibrations. So let me to check, please. 3.1 bar more or less. I want to reduce a bit more in order to get 3.1 more or less. And to get the steady state, to talk about temperature, we must remember temperature has not so fast steady state. It implies we need to get by experiments and the moment as I calculated or by experience more approximated 4 minutes. Between 3 and 4 minutes we target to obtain the steady state. Three bars, 500 RPM, well, 62 point, temperature 0.2 in compressor. My vibrations has trouble with valve and reduce a bit more the pressure. Less than 3. Look at less than 3 bars. And it must be also less than 3 bars here. Of course, less than 3 bars here. 2.9. And temperature continue increasing because it must get the steady state. To wait between 2, 3 or 4 minutes. So you can repeat this experiment and to obtain measurements, but it was a summarized how to work with this monitoring system. Okay, of course it has task in order to get good precision in future, always with your help, with help of the team, to get an artificial intelligence for these systems. So thank you so much.